Good day, everyone. Today we're going to tackle about the fundamental counting principle. This will be part one of the uh, for this topic. So let's proceed. In many real-life problems, we want to count the numbers of possibilities. Counting the possibilities of an event is required to calculate the theoretical possibilities. It's like imagined in the picture on the right. This table will help us list all the possibilities if we toss a two dice together. So the combination could be 1, 1, 2, 1, 1, 2, 1, 3, and so on and so forth until we come to 6, 6. So that's one way on how to count it. For each dot in the dice represent the to a number. Hence, the possible outcomes can be represented by listing the 36 ordered pair as follow. So these are all the possible outcomes if we toss two dice together. The first outcome in the list is 1 comma 1 or 1 1, and the last outcome is 6 comma 6 or 6 6. The list of all the possible outcomes is called the sample space. Where in the sample space, we can see all the possible outcomes. It is a set of possible outcomes. Now, each possible outcomes in the given situation will be called an event. In general, an event is any subset of a sample space, including an empty set. So part of the sample space is what we call the event. This is more specific. For example, uh, list all possible the a combination of two same numbers. So that is 1 1 2 2 3 3 4 4 5 5 6 6, and all of these events are in the sample space. Combining the occurrence of an event or events happen may be solved by calculating the theoretical possibilities. There are several ways to do this. First is by using tree diagram. Second is by using grid table. And third is by systematic listing. So let's start with tree diagram. For example, you are flipping a coins to illustrate. Let us use flipping of coins to illustrate a simple tree diagram. So, tossing two coins. So, draw a tree diagram. On your first toss, on your first coin, you will toss the first coin. So, it could be the possible outcome could be head or tail. Now, on the second coin, second toss, each could be paired with another head or tail, and tail could be paired to another head or tail. So if we going to list all our possible outcomes, it could be head tail head, or tail tail. So all in all, we have four possible outcomes, and this is how we do it in using tree diagram. Another example: tossing three coins. So the process will be the same. In the first coin, list all the possible outcomes, which is head and tail. On the second coin, let's pair all the possible outcomes to head and to tail. Then again, let's pair it again to the head tail, tail head, and tail tail. And after that, we're going to list all the possible outcomes. We have head, 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 tail, head, head, tail, tail, and so on and so forth. So all in all, there are 8 possible outcomes when 3 coins are flipped, namely HH, HHT, HTH, HTT, HTHH, THT, TTH, TTT. Now tossing two six-sided dice is the same. On the first toss, you all your possible outcomes is are the following 1, 2, 3, 4, 5, or 6. Now let's pair them to all possible outcomes in the second toss. So all in that, we have the 36 possible outcomes. So this is how we use tree diagram to illustrate the possible outcomes. Now let us analyze the same example using the grid table. So this is the method 2 of a grid table. So tossing two coins, in order for us to illustrate this using grid table, we just need to create a grid wherein on the column heading we will be writing all the possible outcomes for the first coin. On the row, on the initial row, we will write all the possible outcomes for the second toss. Then we will going to combine them together. So all in all, we only get four possible outcomes as well. Same as using tree diagram. Now in tossing through coins will somehow be different. First, we need to find the possible outcomes in tossing two coins. Then after that, we will use those outcomes and let's pair it to the outcomes in tossing another coin. So these are all the outcomes when we toss two coins together, and this is the outcomes if we toss the third coin. So if we going to combine them together, we will be having this data. So all in all, we have eight possible outcomes. The data placed horizontally across the top of the table show that the outcomes when two coins are flipped. The data listed vertically on the left side shows that the outcomes when the single coin is flipped. The inner row of the column shows that the outcomes when three coins are tossed. Thus, there are eight possible outcomes when three coins are tossed. Now, experiment number two, tossing two six-sided dice. So the same method as we did in the last one. All we need to do is to write at the top all of the possible outcomes when we toss one die, all of the possible outcomes when we toss another die. So let's try to meet each other at the specified box, and we'll be having this as our answer. So all in all, there are 36 possible outcomes. The systematic listing is somehow you're going to list all the possible outcomes systematically. So make all lists of the possible events for tossing two and three coins. All you have to do is to list them systematically. So first toss is head, then it could be head head, head tail, or tail head, or tail tail. So all of those are the possible outcomes when you toss two coins. On the other hand, if you toss three coins, you could be getting this by listing. Just make sure that when you list the thing that it doesn't have any similar listing on the on the on your list, so it will be it will give you an error. For tossing two six-sided dice, again, all you have to do is to systematically. You start by having the first die as one, then pair it with all the possible outcomes 1, 2, 3, 4, 5, 6. Do it in the second dice, third, fourth, fifth, sixth, until you get all 36 possible outcomes. Now note that these three methods can only be used for reasonable number of occurrences or events. In general, we use the fundamental counting principle to determine the large number of occurrences of a certain events without the trouble of constructing table, list, or tree diagrams. On the next tutorial, I'll be showing you how to do the fundamental counting principles without even drawing a tree diagram, list, or a grid. So that's all for today. I hope that you learned something, and goodbye and more power to you.